Morning, everybody. We are going to do part one of lesson 2.5, which is solving equations involving absolute value. Now, what we need to do first is we need to have a little discussion about what absolute value is. And most of you have done this and have covered it, but for a lot of you, it hasn't been since like sixth or seventh grade. So we are going to take a look at that, and then we're going to move forward with it and show how it works with solving equations that have it involved. So I'm going to minimize this here, and we're going to start working away, and I'll move this up here. Okay, so I wrote down a few things here. Follow along with me. Absolute value is loosely defined as the distance a number is from zero. So if I ask you, and if I explain this, and I have some examples below, but if I say, hey, what's the absolute value of 2? So what I'm asking is if you're on a number line and 0 is here, how far away, how many units, what is the distance that 2 is away? And you would just say, oh, that's easy. That's 2 units away. And so it would equal 2. Well, if I did the same thing with you, right? And I said, okay, well, what if we have uh, -3? Okay, then what would my distance away be? Well, you would move your 0 over here, and then you go 1. So you have -1, -2, -3 units away, right? And you would count, you'd say, well, I'm 1, 2, 3 units away. So essentially, what's happening is you're using this number. It's just that if it's negative, it becomes positive. And if it's positive, it becomes positive. And again, that's all because distance cannot be negative, right? Distance is always positive. The distance you are away from somebody, it can have direction, right? And but it's positive, right? So if we look at a few of these examples, we say, so the absolute value of 8 is 8. It's 8 units away from 0 if you did a number line, right? And I'm not going to totally go crazy here. We do 2, 4, 6, 8, right? You're 2, 4, 6, 8 units away. So it equals 8. Same thing with -4. If you have 0 over here and you got -1, -2, -3, -4 right there, you are 1, 2, 3, 4 units away. Okay, so it's always taking whatever is between the sticks, right? And then evaluate it by making it positive. So that is the rule. When you see a number between the signs, right? And we'll call them the absolute value sticks. You evaluate it by making it a positive value. All right, so we're gonna look at a couple of evaluation problems. And this is just plug them in and figure them out. So this first one right here, evaluate m plus 6 minus 14 if m is equal to 4. So what you would do is you would copy this whole thing down with the number substituted in, which we did. We put m in there, right? 4 in for m. And then what you always do is do the stuff inside the absolute value sticks first, all right? Because that is braces, I think they're called, absolute value braces. Because that's following PEMDAS, essentially. It's kind of a bracket, right? So follow that out. 4 plus 6 gives you 10, and the absolute value sign minus 14. Well, the absolute value of 10 is 10. And then once you get rid of your absolute value brackets, it's the same as any normal problem. So 10 minus 14 equals -4. And yeah, you do have a negative answer, and you can get a negative answer because if you look at this, the absolute value signs aren't around the entire thing. They're just around part of it. So that means that if this is a larger negative, then this winds up being a positive. You're going to have a negative answer. And that's exactly what happened. All right, let's try another one. So let's do 23 minus, and then in our brackets. So we have 23 minus 3 minus 4 times, and then I'm going to use a different color just to show that we're putting 2 in, right? So 4 times 2, and that's all enclosed in brackets, just the 3 minus 4 times 2. So let's do the stuff inside the grouping symbols first, all right? So 3 minus 4 times 2 is 8. And then you get 23 minus, and then this is negative 5. All right, so now a common mistake a lot of people will make is they'll forget that these aren't parentheses and that they're absolute value brackets. And they'll go, oh, I'm going to do 23 plus 5 because these turn into, it's a double negative and becomes positive. And no, you can't do that. That's absolutely wrong. Because we have to evaluate the absolute value sign first. We got to deal with this first. And when we deal with that first, you have 23, you still have this minus sign, minus, and then negative 5 becomes a 5 because the absolute value of negative 5, the distance negative 5 is away from 0, is 5. And then it's just 23 minus that, and that gives you 18. So that gives you a very different answer, right? But you have to make sure you're following the process correctly. All right, and that's really the only way these problems will get you. Otherwise, it's just basic substitution. Okay, so now we are going to look at what do we do with equations. So I think the best way to explain this is just to kind of dive into it and show you sort of an example. So if I've got this equation, this f plus 5, which is in brackets equals 17, that means that there are two things that can happen. So the first thing that can happen, and we'll call these cases, all right? And they say case 1 and case 2. And so I usually I say positive case and a negative case. All right, I think that makes a little more sense. It's a little easier to remember. So the positive case of this situation, all right? The positive case of this situation is that whatever is inside this, inside the brackets, all right? Let me highlight it instead. So this stuff right here, whatever's inside the brackets is already positive, and then it equals 17. All right, so that means that this f plus 5 is positive, so I don't have to do anything weird to it or anything, and that already equals, and that already equals 17. Okay, and then in that case, you have an equation to solve, and you can just drop your parentheses, okay, and then solve it the way you would any other normal multi-step equation. Subtract 5 from both sides, you get f is equal to 12. So the first case situation is if f equals 12. But there's another case situation, and that's what if this stuff inside the absolute value brackets, what if f plus 5 equaled negative 17? Because if it equaled negative 17, the brackets would apply to it and then turn it into 17. So that's the negative case. So I think where a lot of people get confused with this is they want to do this. They want to go negative f plus 5 equals 17. And then they're like, okay, what do I do with the negative sign? I got to distribute it. There's a much easier way to do it. And the easier way to do it is we know that this thing inside here equals 17 when it's done. Well, before we apply the brackets to it, it has to be negative, right? So let's just put the negative sign on the other side. And you can do that, right? If you have x equals negative 16, you could also say negative x equals 16. So you can move that negative sign back and forth. So I think it's easier if you put the negative sign on the right side where it's only applying to one term, right? So you have f plus 5 equals negative 17. This is your negative case. Okay, and then you just solve it. So you would subtract 5 again from both sides. That would give you negative 22 because they're both negative. You just add them up and keep the sign. And so you have if you plug negative 22 in here, right, you get negative 22 plus 5, which is negative 17. Take the absolute value of that, it is 17. So it's a positive and a negative case that you do for these. And you set it up as simple as you possibly can. So and then the other thing they're going to ask you to do is they're going to say, okay, and I'm going to write my answers down here. We came up with f equals 12 for one of our answers, and then our other answer was f equals negative 22. The other thing they're going to ask you to do is they're going to say graph this. So all you got to do is you just got to basically set up a number line. Sometimes they'll have them set up for you. All right. And I know I'm going from negative 22 to 12. So maybe let's put 0 here. And then let's just go up by 5s, right? So you get 10, 20. And so negative 22 is going to put us, if this is 0, negative 22 is going to put us about right here. And then 12 is going to put us just past 10, about right there. And then you have graph this. All right. Very good. Let's have you guys take a look at this one. If you want to pause it and think about how you're going to set it up. All right. And then if you want to try the problem, you can. Okay. Let's try this. So we have our two cases. All right. We have our positive and our negative case. So let's do our positive case. So let's say our plus case. All right. Our positive case is this stuff is already positive. Negative 4d plus 6 stays positive and equals 12. And you don't really have to do anything with the absolute value brackets. So let's solve this. All right. So we're going to subtract 6 from both sides. You're going to get 6 over here and negative 4d. Then we're going to divide both sides by negative 4. And then d is going to equal negative 3/2. All right. I'd say graph it, but let's wait and see what our next one is so we know how to set up the number line. So our negative case is this whole thing, negative 4d plus 6, is going to be negative. So we're basically going to have a situation like that. But what we're going to do, if you remember, is we're going to take that negative sign that is here, right? And we're going to move it over to the other side so that instead we're going to have something that looks like negative 4d plus 6 equals negative 12. So we just moved that negative sign over to the other side because it's easier to negotiate. All right, now let's solve this. So let's subtract 6 again from both sides. And you'll notice that your steps are basically the same on both ones. It's just that your right side is different. So sometimes you're doing an addition problem. Sometimes you're doing a subtraction problem. It just depends how you start. You have negative 4d equals negative 18. If you divide both sides by negative 4, now we're going to get a positive answer. And it looks like, and we're going to get 9/2. Right, I just simplified that. I divided both sides, the denominator and the numerator, by 2. You have 9/2. So if we make this 0, let's say this is 0, okay, and we'll make this 1, 2, 3, 4. 9/2 is basically 4.5, so that's going to put that right there. And then 3/2, negative 3/2, so negative 1 is here. Negative 3/2 is between negative 1 and 2. All right, it's negative 1.5. And then there you go. All right, let's look at another one. Now, this problem, I want you to just look at it and think about it, okay? This is saying that if you take the absolute value of whatever 3n minus 4 is, you equal negative 1. Now, think about that. If you take the absolute value of something, what happens to the value inside the brackets? Well, if it's positive, it remains positive. And if it's negative, it becomes positive. So what we have here is we have a situation where there's no solution because distance is never negative. So when you see something like this and you have, and the whole side, all right, I don't know what just happened there, but that was pretty funky. The whole side is in the absolute value brackets, and they're saying that it equals a negative number. That is a solution where you have no solution. Another name for it, sometimes they'll say null set, okay? But no solution, because distance is always positive, all right? The distance something is away from 0 is always positive. Okay, and because there's no solution, you can't graph it, so you don't need to do anything with this. All right, so this is your basic rundown on how to do absolute value equations and evaluate it. And then the next lesson will cover the remainder of this full lesson, and we will talk about writing these equations from a graph and also look at how do we handle some word problems with this. Thanks a lot and have a great day.